Roll film. Hey, 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 everybody. It is 2 hours UTC, and this is Astronomy Daily Live. It's just a daily live stream where a bunch of us come together, hopefully sort of an ever-growing crowd from around the world. This is absolutely amazing. I wonder if our instro is going to come in again. He he or she, not sure, uh, don't care, um, is in Afghanistan, and they've been coming on. It's like 6 a.m. there, or 6:30 a.m. He or she is on a time and a half zone. They're at UT plus 4.5 hours. So yeah, imagine that, having, I mean, uh, it's hard enough, right? Just just subtracting and adding um, uh, integers, right? I mean, but now it's like you have to worry about fractions. It's like, oh man, yeah, that's gotta hurt. That's gotta really, really hurt. But that's what they're up against over there. So let me look at the chat here, see who's in. Our instro is there. Our instro is there. Hey, hey, hey. Yeah, and Tom is around. Uncle Bill is uh, painting the chat yellow as he does. And Uncle Bill, yeah, you might be hearing a faint echo through Bobby's connection. Um, don't know if anything can be done about that. Um, maybe if you mute yourself, Bobby, I don't know. It. I need to. What I need to do is I need to put on my headphones over on the laptop here so I can hear those minute details because I'm hearing something, but it's not very, very strong. So hold on. Okay, there we go. There we go. There we go. So, uh, so hey, everybody. Hope everyone's doing well. Tawahinta is in the chat. Yeah, yeah, pretty good. I'm a early riser, so yeah, 6 a.m. for me wouldn't be too bad either. I'm just I think that's absolutely fabulous. So yeah, very very cool. Thanks for coming in, just to hang around, sort of forget about lots of other things and focus on the universe. So and uh, I sort of chuckle at that, right? Because it's like forget about everything and focus on the universe, which is everything. So yeah, it's that's what I'm saying though, and it's just a lot of fun. So this is just fun. This isn't uh, necessarily to communicate science or communicate astronomy or anything like that. It's not. I'm not really here to educate you um, in any way. So uh, I just uh, I've done astronomy my my entire sort of conscious life, right? And so yeah, it's just it's kind of cool. It sort of dawned on me over a period of time that it's like, look, I'm watching YouTube live streams of people who like music, who like radio, uh, um, who like growing plants, um, uh, a variety of things, right? Live streaming it and just you know sort of doing what I'm trying uh, to emulate. Just a fun, casual get together of friends every single day if you want, every other day, every month, every year, whatever, whatever. So cheers. It is, it is the hydrogen hydroxide again. It's been a while since I've had dihydrogen monoxide. Hmm. Well, I guess I'll have to think about that. It's a very um, energetic molecule, but HOH I find to be very very relaxing and calm. So cheers. Yeah, that's extremely cool, Arinstro. I really really appreciate you coming in to this, right? It's very very cool. I'm honored and much respect. Very very cool. It's really really neat to think about the the fact that there is someone on the opposite side of the planet from this location uh, that is here, right? It's in this virtual circle, and I think it's amazing. And I think this is just a start, right? I think that this is just a start. Um, yeah, I think the next 10 to 20 years, if as Carl Sagan always said, if we don't destroy ourselves, if we don't destroy ourselves, right? Um, 10 or 20 years, it's going to be pretty interesting. Pretty interesting. I think we all uh, are going to see quite a bit more. Already seen. We've already really seen quite a bit, quite a bit. So yeah, I was 7, 8. I was about 8.5, maybe 9 months old. Uh, but I watched Neil Armstrong walk on the moon. So at least apparently I watched it. I've been told. so uh, so yeah. And I actually remember. I've got a very 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 faint memory of uh, sitting on somebody's lap and and seeing a black and white TV, right? And on it, I can extremely clearly, I mean, like uh, very very clear, is a Saturn V launching. So my guess is that that was probably Apollo 17, probably, because that would have been what, 1972, 73, something like that, and I would have been 3 or 4, and so those kinds of memories are there for sure. All right, I'm gonna get this smartphone loaded up here so I can monitor the shenanigans that always seem to occur here. Oh yeah, I've got to mute this. Remember to mute it. All right, well, cool. And as you may have noticed, um, people in chat, there is once again a panelist here. So
Hey, hey, hey.
I think this is very, very cool. There's Bobby. What's going on, Bobby?
Nothing much. Cosmic, what about you?
Everything's pretty good. Pretty good. It's yeah, sort of a busy day, but got home on time and just had a nice chill couple hours. to uh, you know gather thoughts and sort of scan all the new astronomical papers. Posted a few links over on Discord.
Oh,
So and actually, I probably want to take a look at one of those tonight. Uh, all of them are pretty cool, but yeah. So yeah, is it still muggy and hot over there?
yeah, it's more like so. We did have a little bit of rain today. Wanted to cut the grass, but wasn't happening.
Yeah, yeah. Well, any excuse to not have to do that is welcome. So yeah, we're getting into the monsoon season here, and yeah, it's hit and miss with those things. So we right here at this location, I don't think we got very much of anything at all, but in the valley and in the county, southeastern Arizona. Look it up. Look at the radar right now, and you'll see a whole bunch of green down there. So yeah, that's the monsoon. But so it's humid here, uh, meaning that it isn't 10% humidity. It's
Yeah, yeah, we got down to 88 today with a little bit of rain.
wow. Okay. Yeah. So yeah, we get in the mornings and the evenings, we can actually get up to like 70% relative humidity, 80%. Sometimes we get fog. Sometimes we actually get fog. But during the day, it's like 30%, right? And we're just sweltering. So, but it is all relative. Anyway, very cool. So let's let's start thinking and talking astronomical words and thoughts. Cheers.
Cheers.
And I really like this panel thing. I knew that I would, because I've seen it elsewhere, and it's absolutely great. Because the host can eventually just sort of, and that's it, and that's what I'm aiming for. Yes. Um, So, yeah, if anybody's interested in being a panelist, right, it's all you have to do is send me an email, cosmiclettuce@gmail.com, and, just say I want to be a panelist. And on my next live stream and every live stream after that, uh, hopefully I'll remember. uh, I will send you an email with the link, right? And the link um, I can actually get as soon as I start up the Hangout. So uh, uh, as Bobby did today, you sort of get to see all the setup, which is just incredibly exciting. Just like it's just awe inspiring, isn't it, Bobby? It's just amazing. Yeah. So yeah, I'll send you the link as soon as I start the thing up, and then I just have to turn on a light, plug in the mic, and I'm rip roaring, ready to go here. So but cool. All right, so let's get into some astronomical things, and I'm gonna pull up my Discord. So Bobby, you found me through Gilles, right?
Yes, I have.
Yeah, yeah. Okay.
Yeah,
Yeah, I'm I'm trying to remember exactly how that how I alerted him to this. um, maybe I sent him an email. I think I probably did. Yeah,
Yeah.
because that's not something I would blurt out on the chat or anything. I think that's just rude. So I'm not there to take over his
Yeah,
time.
I got him on WhatsApp and stuff, and sometimes he'll join us, and sometimes like he's going to be late. Earlier today, he's going to be late.
Yeah, cool, cool. Yeah, and I found Jill probably mm, I want to say like a year ago or so. Uh, um, uh, yeah, my current boss, he's a radio uh, uh, gadget maker, and uh, and actually he's lots of things, but he's really into antenna design and um, um, making amplifiers for them and all these wild antenna things. And he has um, this pretty interesting design for an antenna that
Yeah,
works.
I found Jill's as more of a tech guy. Whenever I first found him, he was like doing like one of those when's the official main the regular Windows 10 release is going to be,
Oh, okay, I gotcha. Yeah.
and then like about a few years back, like around like 2016, I watched one of his radio shows, and I can never would believe that shortwave is still there.
Yeah, I um when I was well, I guess up until I left home, I had a a sh- and I I have absolutely no idea, right, what make or model this thing was, but it was an old shortwave radio that used the vacuum tubes, right? And these these big these big dials and like you know dozens of switches and all that. And I remember listening, to China and uh, um, South America and uh, Germany, Deutsche Welle. Uh, uh, but I never got into it, right? Because I was on a different rocket, right? I was on a completely different rocket. So it's like, oh, okay, But I would have really liked to have been a little tiny bit more um, interested in that, uh, just because I would have had liked to remember um, a make and model of this thing because it was really cool and it was big, right? It was probably
Yeah.
you
Yeah,
know
when I found Jill's as a radio person, I started listening to other people's radio catches and stuff. The ones that got me familiar the most is the ability to decode digital text and images by Scotty TR6. He's pretty darn good. He also does his captures with DX's Unlimited and that shortwave radiogram, what used to be called BOA radiogram. And he was and the guy behind the BOA and the shortwave radiogram, his name is Kim Andrew Elliott, and he's pretty darn good.
hmm, yeah, cool, cool. Yeah, I I'm still I've got a well, my interest in terms of radio pretty much stops uh, with like Jill's show. That's about as much as I I want. Yeah, I think if I had a little bit more time, a little tiny bit more motivation, I probably would sort of surf around. As it is, sad to say, for shame. Uh, the only time that I use my shortwave radio is when I'm at the telescope and I need to know what time it is. So, so shame, shame, shame. It's a where is it? Do I have it here? Hold on a sec. I'll show it to you. So this is just really, really quick because this is not astronomical in any sense of the word at all. But no, this isn't exciting at all. All right, it's just a DX 397 analog, but it's it picks up a lot of stuff. So, but yeah, I should do some kind of noise thing around here. See how noisy it is. I've got a power plant just up the road, so it's probably pretty noisy. All right, let's do some astronomical things. Show off your radio first.
Yeah, so this is the Tibito B115. Jill's had that radio, and he kind of a bit like it and stuff. So this is like my own, and sometimes it may have some issues and stuff, but it still works like good. And are you into like either like tabletop receivers or SDRs?
I, you know, I, I really like the SDRs. I think that those are I don't know. It's the waterfalls really allow you to sort of see a band, right? Which you can't really do with a tabletop. Um, so yeah, I think um, I would like both, and I would probably use them differently, right? Because they are pretty different.
Yeah, I'm more into SDRs too. I had an RTL SDR and an SDR plate that I'm using right now.
Cool, cool. I've got a kitty here. Hello. He probably needs a servant to open the door, but he's going to pester me first. That's all right. You can pester all you want. Let's do some astronomy. All right, so I'm going to share my screen. Share my screen. Kitty, you're making this difficult.
At least he's not my dog.
I'm going to hide that. I'm getting over here. He's up here just rubbing against the microphone in my hand and trying to be a nuisance. All right, he's settled down on my lap. I can't believe it. I was looking at this one, but this one also looked good. But it was, it's about white dwarfs, and I think we just talked about white dwarfs the other day a little bit. So that's a good read. They're talking about how they're actually their models at least predict that the cores of these very massive white dwarfs actually crystallize. Uh, they've got oxygen and neon cores that crystallize. So yeah, very cool. I mean, they are just models, right? So there's a lot of possibilities with models. So, but this one looked a little interesting. And I haven't looked at this except I read the title and read the abstract, and that's about it. So they're talking about these convolutional neural networks, recurrent convolutional neural networks. I don't know what that means. Uh, but as an input, it uses a sequence of images. Uh, let's see. This approach avoids the yeah. So this is the interesting thing for me because I've done a lot of work with detection of moving objects in the sky, and you know that's what this is. That's at least one of the applications of this, and and uh, and so they say that you don't have to compute light curves or difference images. Uh, you know, you compute a difference image to see if anything has moved in the image. Anything that isn't in image uh, or that is in image 1 and 2 in the same place. When you subtract those, they're going to go away. But anything that has moved, uh, you'll definitely see it. It pops out. But they're saying that using this thing, they don't have to do that. And I don't know. I don't know how that's done. But let's see, I thought somewhere in here. Yeah, uh, so they tested it on some um, synthetic images, and then tried it on some real world images, and I guess I guess that would be like 87%. I don't know. I don't know why it just says 87, but I think that's supposed to be 87 percent. I guess. Um, so that's pretty good. That's pretty good. Being able to identify objects with a 87% probability that they're right. So that's not too bad. So they were looking at supernovae, um, kind of variable star called RR Lyrae, uh, non-variables. I'm not quite sure what that means. Non-variables. What's a non-variable? Hmm. Hmm. Okay. Anyway, so they compare the results of their model with those of the light curve classifier in both simulated and real data. So their model outperforms the classifier uh, due to extra information contained on the images. Okay. The results obtained encourage us to use and continue developing the method. Yeah, very, very cool. Yeah, see, I mean, what these guys are working on, right, is they have they have heard, and it's absolutely true, I guess, that when the LSST comes online, that's the Large Synoptic Survey Telescope. There are going to be in excess of 1 million alerts every single day. And an alert is any kind of transient event. So when if it sees anything move, if it sees anything new, if it sees, I mean, any kind of transient event at all, uh, that that's going to prompt some kind of an alert. So you're going to have a million of these every single day, right? so so you have to be able to you know, process that kind of information and look for things, right? So I think that's where these guys are going with that, and I think it's very cool. So let's dive into it. What do you say, Bobby? Is this a good dive?
Um, it's a I can it they can if like I say it's just a prototype right now, right?
It's uh they are trying to teach this neural network how to identify various events given a sequence of images. Uh, yeah, yeah. It's I mean, you know, uh, I guess this is um, sort of combining uh, uh, you know, the astronomical stuff with the
I,
computational stuff.
I think if they can like enhance it and stuff, I believe like the learning quality of it would be like superbly good than our older models.
Yeah, yeah. Well, I think they're doing pretty good um, if that actually is, you know, like an 87%, which I assume it is. Um, let's see. For some reason, I have to reload my. There we go. And let me mute that again. There we go. Okay, cool. Well, let's dive into it and just sort of see. These are the kinds of things that are like maybe just sort of out of my reach. I don't know. I programmed some neural nets. They're actually pretty well. The basic ones are pretty easy and very cool because they really do learn and they are pretty good uh, at figuring things out. It's pretty amazing and relatively easy to program. Let's see. I'm going to zoom this up a little bit here. That was that's the abstract, of course, that we just went through. Okay, yeah. Here, first paragraph is exactly what I just said. You know, it's like LSST is just going to blow everybody's minds. They're talking about 10. Did they say 10 terabytes a day? I think the entire Sky survey is going to be something like 500 petabytes. So it's just absolutely insane. Lots and lots of data. Let's see. Study variable stars and transients. Um, variable stars, pulsating stars, or eclipsing stars, supernova explosions, uh, all those things in large numbers. They say. So these objects have characteristic timescales from hours to months. So yeah, you know, the temporal aspect of all of this too. Um, okay, so Bobby is blowing up our speakers. I think can I think I can do that, right? Let's see if I can do that. Thanks for your patience. I'm gonna see if I can turn you down, Bobby. I'm gonna turn you down. Okay. Now, come on back up and give a holler.
Test 1 2, test 1 2.
There we go. that was much reduced for sure, for sure. So, Uncle Bill, let me know if that's okay. And then, yeah, I'll just have to remember to do that. I don't know if you have any kind of volume control on your end. I don't
Yeah,
know.
I'm on a Chromebook and I'm on my Chromebook S so my microphone can work. I was gonna try it with my Bluetooth speakers because it's got a microphone. But if it wants to have that audio, that echo that you had last night,
Yep.
it would be wrong if I did use my Chrome OS mode on it and use my internal stuff.
Okay. They're saying I should turn you down even a little bit more. So I'm going to try to turn you down a little bit more. Can't turn you down too far. Okay, try it now, Bobby.
All right, 1, 2, 3, 1, 2, 3.
Yeah, I think I've got you turned all the way down. So let me. Okay, now try it.
1, 2, 3, 1, 2, 3.
Turn you up a little bit more. I can't hear you.
1, 2, 3, 1, 2, 3.
There we go. Try it right there.
1, 2, 3, 1, 2, 3.
How's that? Much better? That's good. Okay, cool. All right. I will endeavor to remember to do that. That'll be one of my new jobs. Okay, cool. Yeah, you guys just have to let me know those kinds of things because there might be something that I can do about it. So, yeah. All right, let's go back to this thing because I'm sort of interested. I mean, what I encourage uh, all of us to do, and what I'm going to show you an example of here that I've showed you many, many, many times, and that is, let's look at the pictures. Let's not get too hung up on all the words and explanations and everything else. Let's, you know, this is just an introduction, right? So they're just sort of laying out the problem and what they think they want to do about it. So they built some fake data, which is always a good idea because the cool thing about fake data, right, is that you make it, right? So you know exactly what parameters went into making that data. And so
Sounds
you
like a
can,
plan.
yeah, yeah, yeah. So you can take that data, feed it into your, uh, you know, learning engine, and see if it learns the right things. And then if it doesn't, then it's like, okay, well, we have to tweak this a little bit. Um, so and that it works when what it's it's supposed to get um, out of the fake data is what it actually gets. Then you sort of say it's like, okay, well, this seems to be learning the right thing, right? It seems to be working. So then, so that's what all this is about, right? Trying to, you create some um, artificial data that all the parameters, and so you can see how well it learns, right? Um, so that's what all these things are. And then you turn it loose on real data, uh, assuming that it has learned what it needs to learn in order to identify these these things. So so a non-variable object is constant brightness value for each time of observation. So, okay.
So this is like from the fake data or from the real data.
They they created the fake data first. So fake supernovas fake variable stars, fake galaxies, fake asteroids. But of course, they knew exactly what the parameters of all these things were. So, as I said, if this network learned things correctly, it would, look at the asteroid data and say, okay, I found, this number of asteroids um, at these locations, with this kind of motion, this kind of brightness, whatever. Uh, and if it matches uh, the fake data, then it must work. So yeah, and most likely what they did, right, is they took at least a few of these in terms of real data. That's probably the next section. So yeah, I'm not going to get into a lot of this, um, like curve examples. So yeah, I'm not going to get too excited about too much of this. Image simulation process. The light coming from the source is spread in the source image. Okay. Okay. Yeah. Just creating pictures. Okay. So here they're talking about how they set up this neural network, and I'm definitely not going to get into this. This is one more or less beyond me, but I think given a little bit of time, I could probably remember most of what I learned. A convolution is a mathematical uh, tool that's uh, uh, it's you to convolve two things, you actually uh, put the data. Well, you represent the data in a different way that allows you uh, to multiply them, uh, and then you sort of do the inverse of what you did. You have to put it into that different space, and what you get is a convolution of those two things. It's a very mathematical thing, but it's actually very, very natural. The closest analogy is like superposition. So it's sort of like the sum of two or more things. That's sort of what a convolution is. Let's see. Yeah, just lots of models. Sequence classifier architecture.
Is it possible that it could do like 4K or 8K or any better than that?
4K, 8K. I don't know if I'm following you.
Well, I'm talking about it, if they can get this done, about how good of a picture we're gonna see about that. What's the resolution and all?
Okay, yeah. No, this particular thing just identifies uh, 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 like events, right? So it's not actually doing anything to the images or anything. The images are just coming in as a sequence, uh, which is pretty much what these survey telescopes are going to provide, right? It's just sort of like a sequence. And this particular neural net, they're claiming, does pretty well for identifying those kinds of events. See, LSST, um, those alerts are probably just going to be, like a right ascension and declination and a time, because that identifies it as something at this time at this location happened that you know was unusual, right? There was some kind of change. So that's what the alerts are going to give. And so then, right, you'll be able to go to these images and run a sequence of these images through this neural network, and uh, it has a 87% chance uh, of properly identifying what that event is. So, I mean, if you have a million events a day, that you have to look at all this data, right? Some kind of sequence of images. That's a lot of work. So people cannot do that. It's just too much. It's way too much. But computers do it really, really well. So yeah, I think it's cool.
Yeah, interesting as well too.
Well, these are the kinds of problems. I mean, this is a good problem to have, right? We have too much data, and I mean, it's just going to be getting worse and worse and worse and worse and worse. um, but it's a good kind of problem to have, but it's still a problem. So we need to figure out ways to deal with it. And this, I think, is absolutely fabulous. You know, this may not end up working, right? But I think the idea is absolutely fantastic because um, I mean, we're not going to be able to, by ourselves shuffle through all this. It's just going to be too much. I mean, 10 terabytes a day, right? So the only way to do it is to teach these machines to identify patterns. So very, very cool.
I guess if computers can do it, it's better than getting a migraine all the time, and
Mm,
you know what I mean.
yeah, yeah. Well, Clyde Tombaugh, the discoverer of Pluto, um, he spent, I think he spent about 8 months. I think it was a little bit less than a year, or maybe a little bit more than a year. Um, I forget exactly. I want to say about 8 months or so. Um, uh, you know, photographing relatively large patches of the sky at two different times, right? So he'd take an image, and then a couple nights later, um, um, he'd take uh, um, the same image, basically the same image, and then he would put one of these pictures on the left and another one on the right, and he would look at them and blink in between them, and just by eye see if anything sort of moved in the right way. And yeah, I think he spent like 8 months or 9 months or 10 months, I forget exactly, photographing the sky, and then looking for these faint little dots moving around. Just ah, uh, you know, computers drive me crazy, right? But in order to do astronomy, oh man, you need, I mean, I use my machines as computers, right? These things actually compute. They don't, I mean, I use them, of course, also, for surfing the web and doing the Twitter and all that kind of stuff, right? But when it comes down to it, these machines are here for work, and I make them work.
If you got a reason, do it.
Yeah, yeah. I like computers that actually compute things and don't just relay information and display pictures. That's I sort of feel sorry for them if that's all they do. because that's not what they're made for. Let's see. Okay, yeah, they're talking about filtering data to find the best ones in order to teach the network. That's very cool. Yeah. So yeah, always wanting to improve, and that's a good sign. That's a good sign. All right, let's do. We haven't done an object of the day in quite a while, so I say that we do that. And so what I'm going to do is let's just do an NGC object. I'm going to go over to
How long has it been since we did a
random.org.
Messier object?
What's that, Bobby?
How long has it been since we did a Messier object?
Oh, it's been a little while. Do you want to do a Messier instead?
We can?
Let's do a Messier object instead. So yeah, there's 110 of those, and these are going to be galaxies, globular clusters, open clusters, planetary nebulae, or gaseous nebulae. Uh, Now, some of the Messier objects, a couple of them are sort of like, what exactly is this, right? I think it's I want to say M73, M73, M72, I forget, is like 3 stars. um, and I don't know if they're associated with one another or not. So there's some questionable objects that we sort of have to think about. What exactly did Messier see? I mean, he was a comet hunter, so I think that pretty much everything he saw looked like a comet. And so did 3 stars next to one another with 18th century telescopes, mid 18th century telescopes. Did 3 stars sort of close to one another look like a fuzzy blob? I don't know. I've got a problem with um, a lot, especially like the open clusters. How I don't think he necessarily mistook them for comets, but I I I'm pretty certain he wasn't quite sure what they were. All right, so there's 110 of them every single year around the spring equinox. There's an opportunity to see all of them except one. You can't see M30 because it's in conjunction with the sun. So when the sun is up, that's where M30 is. So you just aren't going to be able to see it. But you can see 109 of the 110 Messier objects in one night. So that's called the Messier Marathon. And Atta, uh, once you know once you sort of get used to your scope there, uh, even it would that the Messier Marathon would even be fun, I think, if you use the go-to. But it's extra fun and extra uh, um, stressful um, when you have to find them yourself. So that's something for you, I think, to look forward to. It's really really fun. It's really really fun. It's exhilarating. Um, it, it it definitely keeps you on your toes to be able to see all 109 in one night. Now, uh, when I was doing it, uh, uh, we were real hot shots, right? We were like, 109, is that all? So so we would um, me and a couple of us would clear a sky of Messier objects in a couple hours. But so then we would have to wait 2 or 3 hours for sort of the next sky to come up. And so in between Messier objects, we do um, NGC objects. So I think one marathon night, I think we did something like 285 objects total, something like that. It was insane. It was very insane. But uh, and of course, not all of us were doing that. What we do, I think we had like 2 or 3 telescopes. I think we had three telescopes. There were three of us, and we'd each go after a different one, right? Uh, and then when we had it, right, we'd look at it, we'd note it, note the date and the time, and then we'd run over to somebody else's telescope and look at a different one, note the date and the time. And so we were running between telescopes like the entire night. It was absolutely madness. All right, here we go. Yeah, it's a fun challenge, and it's harder than you think. It's harder than you think. M104. Hey, this is one of my favorite ones. This is the Sombrero Galaxy over in. It's over next to the constellation. Is it Corvus or Crater? I don't remember. It's just south of Virgo. Let's go over to Simbad. Simbad is the awesome astronomical database. You can search for anything here, right? So, I mean, it doesn't have to be a galaxy or a cluster or anything. You can look for individual stars in this and get the same basic information. But M104 is NGC 104. Nope, M104. There we go. That would have been a disaster. So M104, and you know what? You know what we should do, because I know for a fact that the HST has looked at M104. So come on, we have to look at the
So that
galaxy
HST should
with
should have all looked at that Messier objects, right?
you know I would, but that's not necessarily, not necessarily. But I know for a fact that they've looked at M104. For a fact, there's going to be gobs of images here. Well, I guess not as many as I thought, but still quite a few. All right, let's just start at the beginning here, 2015. Let's see if we can get this. See what it looks like here. I don't see anything. Oh, okay, maybe. Yeah, okay. Let's look at this one instead. This is going to be with pick 2, but that's okay. Here, that's more like it. So remember, this is this is reversed, right? So the bright stuff is really, really dark, and the dark stuff is really, really bright. Uh, let's see, what was this? Well, let's see if this if these three are the same field of view. Ooh, no, it doesn't look like it. Looks like they just looked at it with one wavelength there. So let's let's look at this one. I'm just I'm trying to find an excuse to make a picture. I'm not really seeing much there either. Don't know what they're after. Another whiff pick. ACS. Yeah. Two. There's three different wavelengths. That's pretty awesome looking. Let's see if the and whoops. Well, look, I think what I'll do, I'll grab these and mess around with them a little bit. I'm trying to be sort of aware of the time here. So let's get into this guy a little bit. Commonly called the Sombrero Galaxy. Is this? Do we have an SDSS? We do. Let's look at SDSS if we can. Does it remember? Yeah, no, it went back to. Anyway, there we go. So you can sort of maybe appreciate a little bit why it's called the Sombrero Galaxy. It's got this sort of this rim. It looks like a hat or a sombrero, but this is really some dark material, some really, really, really dark, thick material here. So kind of an unusual galaxy, right? Not your typical galaxy. And for sure, we're going to be seeing a lot of other galaxies around because, as I said, this is just south of Virgo. So we're going to see some other galaxies around, a little bit at least. But of course, that one just absolutely dominates. Actually, really not seeing a lot of other galaxies. I thought that we would have seen a little bit more than that. Oh well. Anyway, it's a pretty one for sure. Corvus. That's it. This is Atta. This is a target for you. I think you're going to have to wait though, because I think that's I think the sun is actually probably in Virgo right now, right? Uh, yeah. So you might have to wait a couple months and catch it in the mornings, but this is definitely a good target for your scope, and it's super easy to find, super easy. You just have to bounce off a couple of bright stars. Yeah, really easy, and you'll be blown away when you see this with your own eyes. It's absolutely gorgeous. Absolutely. And it's pretty bright, as you can see. I mean, it has a V magnitude of 8. So, that's sort of right in the middle of the visible uh, band. I think around 5,500 angstroms or so. And it actually gets brighter in the infrared. You see JH and K. I think K is like 2.2 microns, 22,000 angstroms. Let's see what else we got here. Lots of different names. Lots of different names. Not surprised. Of course, it has an NGC object um, number there as well. Of course, it's an NGC object. Lots of papers, lots and lots of papers. Almost 1,200 of them. Oh, well, let's see how far away it is. Oh, is it? Is the sun M104 is still visible at sunset? Huh. Okay. Okay. I'll uh, I'll take your word for it, Uncle Bill. You're looking at the sky. Cool. So yeah, it looks like there's not too good agreement here with distances. Well, we're going from 9.1 up to 21.7. That's quite a spread there. But let's see. 9 and 21 is 30, so the average of that is 15, right? So let's just take 15. So 15 million parsecs. So a parsec is 3.26 light years times a million. So that's a megaparsec. And I'm going to multiply that by 15 to get wow, so that's pretty close, right? 48.9 million light years. Relatively speaking, that's very, very close. It's very, very close. So yeah, pretty much backyard. Uh, not not part of the local group. The local group, I think, is confined to, I don't know, 5 million light years, something like that. So this is almost 50 million light years away. So pretty amazing, right? To think about the fact that when you look at that, right, with your own eyes, the light that you're seeing from that object started from that object 50 million years ago. And you're lucky enough to have those photons enter into your eyes. I think it's amazing. Pretty good on velocity. It looks like it's moving, away from us at about 1,000 kilometers a second. So that's a pretty good clip. See, I don't know what these are. That looks like little spectra of some sort. Should we look at one of these? Let's see. That didn't I don't know where exactly that took us. Oh, the proposal. Okay, let's click on that. Probably not going to look too good. I don't know. It's coming from ESA. Okay, I'm not exactly sure what we're seeing here. Looks like a spectrum over here. It's really hard for even me to see, so sorry. Probably not worth showing off too much of that. Let's see, there's an image here. Let's see what it shows. Oh, it's connecting. It's a slow connection. Yeah, it's It's sort of a weird kind of pass, though, right? It's not finding it. Forget it. Let's look at the at some of the papers here, because Atta, everything is happening right now, but yeah, it's like now sort of depends on, I guess, where you are in relation to other things. So yeah, it's just pretty weird, pretty weird to think about for sure. I think it's a little too weird. So that sort of tells me that we probably don't have it quite right yet. I think once we sort of have things a little better, or maybe even right, it'll be like, oh, of course, it'll be obvious. But it's hard to see things uh, uh, when you're not looking for them. Tests of low mass X-ray binaries in the outer halo of NGC 4472. Yeah, that's not M104. These are all papers that supposedly reference um, M104 in some way. Mention it or something. Whether it does or not, is up for question. Let's see if we can find something that actually mentions M104 in the title. Slugs survey. So yeah, this galaxy is definitely close enough to be able to see globular clusters in it. So that's very cool. Um, I don't see M104 in that either, right? Because it was like NGC 4. What was it? Go up in here and look. 4594. 4594? No. I don't know what it's doing there. 528. Can we do this? Cheating now. Evidence for the nuclear radio jet and its structure down to less than 100 Schwarzschild radii in the center of the Sombrero Galaxy. Stellar halo of M104. So they're looking at planetary nebulae in M104. That's pretty cool. So there's more globular clusters in M104, stellar content, and kinematics. Kinematics is just how things are moving. Photometric study of the inner disk of M104, 1991, Astronomical Journal. So they're trying to use globulars as distance indicators. 1986. Wow. 1977. Okay, that's it. Let's look at the planetary nebulae really quick, and then we'll call it. Let's see if we get some joy here. Oh, I'm being spoken to. Hello. Come on up here if you want. There you go. Okay. Kitty in the lap. Alert, alert. Survey for planetary nebulae. For planetary nebulae out to 16 kiloparsecs. 294. They found 294 planetary nebulae. Wow. Wow, that's amazing. Is that cool or what?
Hmm. Interesting.
I want to see some pictures of that. I want to see some planetary nebulae in a different galaxy. So, as you can see there, there's a negative of it. Oh, what's that? Top panel shows that. Bottom panel shows the survey fields plotted to the same scale. Okay. I guess the dots. The open boxes are the positions of the planetary nebulae.
So there's a possibility for planets.
No, a planetary nebula is a at least as the story goes, is the um, end state of a star, like our sun. Our sun is going to end up from the outside looking like a planetary nebula, like the Ring Nebula. Have you ever seen that? You probably have. Let's can pull that up really quick and easy. So here's a prime example of a planetary nebula. There we go. When these objects were first discovered, nobody knew what they were, except that they could see that it had some size to it, right? It wasn't a point source. It had some size. And the only other things that they knew of back then that had some size to them were planets. So they called these planetary nebulae. It's a horrible name, horrible name. But this, from the outside, this is sort of what our solar system is going to look like once our sun becomes a white dwarf. About 5 billion years from now. So these are the kinds of things that they were seeing inside of this other galaxy 50 million light years away. Very cool. See if we can get some pictures here. We looked at a bunch of planetary nebulae the other day. Remember all that? I think we went through like 100 of them. I'm not seeing much, just a lot of names and a lot of identifications. Scientists love numbers and designations and things, don't they? Some kind of obsession, right? Got to have all these numbers. So they're looking at, various relationships here, seeing if they can understand. It's like, okay, if this changes, then this changes, and that means something. Yeah. Okay, well, I'm not really seeing any pictures, right? I'm just seeing a lot of lists. Yeah, it's kind of a bummer. But we're gonna go with it. I think I'm gonna get out of here for this time around. Let's see. Yeah, I popped back in. All right, very, very cool. I think I'm going to get out of here for now. Thanks, Bobby, for coming in
No
again.
problem.
As I said, I'm as long as I remember, I'll send you an email, and that goes for anybody. Let me know if you want to be on the panel, and I've got to learn a little bit more about getting the panelists a little bit more involved. I just have to remember to do that. So yeah, it'll be very, very cool. So thanks for coming on, Bobby. It's great. It's great,
Yeah, great show.
and I think it can only get better. I like the idea of having a panel because it's it's sort of we're just a little bit more here. Being on the chat uh, is great, and do what you want. But coming onto the panel, I think is going to be very, very cool. So yeah, let me know if you are interested in that. Oh, just a quick update on the camera. So I was notified that the camera was delivered on Monday to my mailbox. And so Monday there was nothing, and Tuesday there was nothing, and Wednesday there was nothing, and Thursday, today, there was nothing. So this morning, went to the post office, told them about it, and they're going to check it out and hopefully give me a call. But don't know, don't know. It's up in the air, so it's floating out there somewhere. Who knows? All right. That's, that is the limit of my excitement. That's about as exciting as it gets around here. So take care, everybody. I will see you on the spin tomorrow. Tomorrow. All right. Thanks for coming in, everybody. See you later. Bye.